Hey everybody, it's Mr. Carr again. Today we're going to be looking at 7.1 day 2. Focus here is going to be what's called arc length and sector areas. So first of all, arc length, that is a portion of the circumference of a circle. Meaning if I have a circle, okay, we're just going to be looking for something like this. How far does it go from here to here as an example? Okay, the sector of a circle is going to be a region that's bounded by two radii of a circle and their intercepted arc. So you kind of see a picture below here, but to kind of go off of this name here like this, if I just draw in two radii here and here, we basically create this piece of pie. This is my sector. It's bound by the radiuses and the arc right there. So that's a sector. What we're going to try to find today is we want to find an arc length. So what is the actual distance to go from point A to point B here, as well as the area of a sector. So one of the biggest things I want to point out is that because we talk about this arc length as being a portion of the circumference, then we can set this up with with a ratio. So in a circle, the ratio of the length of a given arc, which I'm going to call L, to the circumference C is equal to the ratio of the measure of the arc M to 360 degrees. So it's always going to be arc length divided by circumference equals the measure over 360. Okay. I'm going to set these up because it's a portion like this. I'm going to solve them with cross multiplication. So that's how I'm going to do all my problems here. So we want to find the arc length of AB. So that is the distance going from here to here. So again, using this setup here, the arc length is what we're solving. So I'm going to put L here. My circumference is going to go underneath. So that is 2 times pi times the radius of 2. Okay. The measure is 88 degrees. That's given, and that's over 360. Okay. So I can cross multiply this. So I've got 88. So I'll have 360 times L is equal to 88 times 2 times pi times 2. Then I can divide both sides by 360. And then that means I'm going to plug this into my calculator. I just plug that all in just like that, and I get my answer, which comes out to about 3.07 millimeters here. Okay, so in this case, if we have 12.3 is the radius, we want to find the arc measure of RS. We want to find the arc measure. So we're going to still use that same idea, but we're going to look for what is the degree measure going from here to here, because we have the arc length of 38. So we're trying to find M in this case. What is the M degrees that would be the arc measure? So we're going to do the same thing. Arc length is going to go on top. Circumference will go on bottom. So since this is the radius, it's 2 times pi times 12.3. And that equals to M over 360. So instead of doing the whole cross multiplying, I'm just going to multiply both sides by 360 here. So this will be multiplied by 360 here. So that way that cancels out. So what I'm going to have is 38 times 360 divided by 2 times pi times 12.3. The biggest thing here is making sure you put this in your calculator properly. I highly suggest that you create the fractions just like this. Okay, so don't mess with the division symbol, just always put it as a fraction. It's much easier to keep track of that way. So when I do that, I get 177.01 degrees for my measure. Okay. The other thing we're going to do today is area of a sector. Well, this works exactly the same way as our area of as our arc length. The area of a sector is a portion of the whole area. So if I take the ratio of a sector of a circle, I'll call that S, to the area of the whole circle, that'll be A, is equal to the ratio of the measure of the intersected arc M to 360. So the idea here is that sector area over circle area is equal to measure over 360. That's my setup every time. Okay, and we're going to do the same thing. We can do cross multiplication with that. So we want to find the area of both sectors formed in here. So we'll start with this one. This is 63 degrees. My radius, here it is. My radius is 5. So that means my sector area is going to be sector area over circle area, which is pi times 5 squared, is equal to my measure 63 over 360. Okay, so I can cross multiply here so that I have 360s is equal to 63 times pi times, I'm just going to write 25 because that's the 5 squared. Finally, I divide both sides by 360. And again, this is what goes in my calculator, just like that. Okay, so my sector area is going to come out to 13.74. We don't have any units, so I'm just going to say units squared. So it's no feet or inches or anything. So I'll leave it like that. Now, the second one, I'm going to do a similar thing. The way I'm going to do that is I'm going to first find out what is my arc measure going the other direction around. So this is going to represent the blue one there. So to find that, remember from before, we take our entire circle 360 minus the minor arc of 63. So that comes out to 297 degrees. So now I'm just going to do the same exact process, but instead of 63, I'm going to use 297. So that's S over pi times 5 squared is equal to 297 over 360. So then we can cross multiply. So 360S equals 297 times pi times 25 again. Then we divide both sides by 360. So S in this case comes out to 64.80, and this is going to be units squared again. Okay, and that is actually it for today. So again, the main idea here, if we need to find the arc length, so it's a portion of the circumference, we can set up a proportion where we do arc length compared to circumference is the same as the arc measured compared to 360. Then the other thing we did was area of a sector, which again, area of a sector is a portion of the entire circle's area. So we could do the same kind of a setup. The ratio of the sector compared to the area circle, the area of the circle is the same as the ratio of measure to 360. Okay, and that's it for today. So take care, everyone.